On July 5, 1943, Lieutenant Ivan Zhdanov of the Soviet 3rd Mechanized Corps saw a tank he didn't recognize. He was commanding a T-34-76 near Ponyri, part of the northern sector of the Kursk salient. The German tank was approximately 100-200 meters away, advancing through morning mist with other panzers. The silhouette was wrong. The turret was too large, the hull was too angular, the gun was too long. This wasn't a Panzer IV, it wasn't a Tiger, it was something new. Zhdanov ordered his gunner to fire. The 76mm round struck the German tank's front glacis at approximately 800 meters. The shell deflected upward and tumbled away into the sky. No penetration, no damage. The German tank continued advancing. His gunner fired again. Another hit, another deflection. The shell ricocheted off the angled armor without penetrating. Zhdanov watched through his periscope as the German tank's turret traversed toward his position. The long 75mm gun elevated slightly. There was a flash and smoke. The armor-piercing round hit Zhdanov's T-34 low on the front hull. The shell penetrated, traveled through the fighting compartment, and killed the driver instantly. The tank lurched to a stop. Smoke began filling the interior. Zhdanov ordered his crew to bail out. They abandoned the burning T-34 and took cover in a shell crater 50 meters away. From the crater, Zhdanov watched the new German tank destroy 3 more T-34s in rapid succession. Each time, the German tank fired once, scored a hit, and the Soviet tank exploded or began burning. The Soviet return fire was hitting the German tank repeatedly, but the rounds were deflecting off the sloped armor without causing damage. That was Zhdanov's first encounter with the Panther tank. The Panzerkampfwagen IV Panther, Germany's answer to the T-34. A medium tank with heavy armor protection achieved through radical sloping, a high-velocity 75mm gun that could penetrate any Allied tank at combat ranges, and mobility that allowed it to maneuver across the battlefield. The Panther represented a fundamental shift in German tank design. Before the Panther, German tanks emphasized mechanical reliability and combat-proven designs. The Panzer III and Panzer IV were workhorses, reliable, simple to maintain, adequate for their roles. The Tiger I was powerful but expensive and complex. Germany needed a tank that combined the T-34's sloped armor and mobility with German engineering quality and firepower. The Panther's development had begun in November 1941, shortly after German forces first encountered the T-34 in combat. German tank commanders were shocked by the Soviet tank's capabilities. The T-34 had sloped armor that was effectively thicker than its actual measurement. A 45mm plate angled at 60 degrees from vertical was equivalent to approximately 90mm of vertical armor in terms of protection. German 50mm and short 75mm tank guns struggled to penetrate the T-34 at combat ranges. The T-34 also had wide tracks that gave it excellent mobility in mud and snow. It had a powerful diesel engine that was reliable and less flammable than gasoline. It had a 76mm gun that could destroy any German tank then in service. The T-34 wasn't perfect. It had poor crew ergonomics, limited visibility, and crude manufacturing, but its combination of firepower, armor, and mobility was revolutionary. German military leadership recognized immediately that they needed a response. In November 1941, the Waffenamt, German Army Weapons Agency, issued development contracts to Daimler-Benz and MAN, Maschinenfabrik Augsburg-Nürnberg, for a new 30-35-ton tank to counter the T-34. Daimler-Benz submitted a design that was essentially a German copy of the T-34. It featured similar sloped armor, a diesel engine, and comparable dimensions. The design was straightforward and could be produced quickly. MAN submitted a more conventional German design with a turret mounted farther back on the hull, a gasoline engine, and torsion bar suspension. After extensive evaluation, the MAN design was selected in May 1942. The decision was controversial. The Daimler-Benz design was closer to production-ready, but the MAN design had advantages in crew layout, gun mounting, and potential for future upgrades. Hitler personally influenced the selection, preferring the MAN design's appearance and layout. The selected design became the Panther. Development was rushed. Germany was suffering heavy tank losses in the Soviet Union and needed a replacement urgently. The first prototype was completed in September 1942. Testing revealed numerous problems. The transmission was underpowered for the tank's weight. The engine overheated. The final drive gears failed prematurely. The suspension was overloaded. Engineers worked frantically to fix these issues while production began. The first production Panthers rolled off assembly lines in January 1943. These early tanks retained many of the prototype's problems. The transmission and final drive failures were particularly severe. Panthers would break down after 150 kilometers of operation. Some tanks failed before reaching the front lines. Despite these problems, Hitler ordered the Panther into combat for Operation Citadel, the planned offensive at Kursk. The attack was scheduled for July 1943. Germany would deploy over 200 Panthers in the offensive, concentrated in the northern pincer. The new tanks would spearhead the attack, breaking through Soviet defenses with their superior armor and firepower. The Panther's armor scheme was its most revolutionary feature. The front glacis plate was 80 mm thick, angled at 55 degrees from vertical. This created an effective thickness of approximately 140 mm against incoming rounds. The lower front plate was 60 mm at 55 degrees, approximately 105 mm effective. The turret front was 100 mm at approximately 12 degrees, roughly 110 mm effective. The gun mantlet was 100 mm spherical. This armor scheme made the Panther nearly immune to Soviet tank guns at typical combat ranges. The standard Soviet tank gun in mid-1943 was the 76 mm F-34, mounted on the T-34-76. At 500 meters, this gun could penetrate approximately 90 mm of vertical armor. Against the Panther's sloped 80 mm glacis, 140 mm effective, the 76 mm gun had essentially zero chance of penetration at any combat range from the front. The Panther's own gun was the 7.5 mm WWII 42L70. This was a high-velocity weapon with a 70 caliber barrel length, 70 times the bore diameter equals 5.25 meters. Muzzle velocity was 925 meters per second with armor-piercing ammunition. At 1,000 meters, the gun could penetrate 138 mm of vertical armor. At 2,000 meters, it could still penetrate 106 mm. This meant the Panther could destroy T-34-76 tanks at any combat range from any angle. The T-34's maximum armor was 45 mm on the front glacis, angled at 60 degrees for approximately 90 mm effective thickness. The Panther's gun could penetrate that at ranges exceeding 2,000 meters. The engagement was asymmetric. The Panther could kill the T-34 from 2,000 plus meters. The T-34 had to close to point-blank range and hit the Panther's side or rear armor to have any chance of penetration. On paper, the Panther was superior to every Allied tank in service in mid-1943. In practice, the mechanical problems were crippling. When Operation Citadel began on July 5, 1943, the German offensive deployed approximately 200 Panthers. By July 10, more than half were out of action. Some were destroyed in combat. Most broke down from mechanical failures. The most common failure was the transmission and final drives. The Panther's combat weight was approximately 45 tons, significantly heavier than the designed 35 tons. The transmission was overstressed. Under combat conditions, frequent acceleration, hard turning, traversing rough terrain, the gears wore rapidly and failed. When the final drives failed, the tank was immobilized and had to be towed to rear areas for repair. Engine fires were another serious problem. The Maybach HL230 P30 gasoline engine produced 690 horsepower but ran very hot. The cooling system was barely adequate. Under sustained operation, particularly in summer heat, the engine would overheat. Gasoline leaks were common due to vibration. A hot engine plus gasoline vapor created fire risk. Panthers would catch fire spontaneously without being hit by enemy fire. The fuel pumps also failed frequently. The high-pressure fuel system was complex and sensitive to contamination. Poor quality fuel or dust ingestion would cause pump failure. When the fuel pump failed, the engine stopped. The tank was immobilized until repairs were made. Despite these problems, Panthers that reached the battlefield and remained operational were extremely effective. Lieutenant Zhdanov's experience was typical. Soviet tank crews found that their 76mm guns couldn't penetrate the Panther frontally. They had to maneuver to the sides or rear, which exposed them to the Panther's gun. The kill ratio heavily favored the Panther when mechanical issues didn't intervene. German tank ace Ernst Bachmann commanded a Panther during the Normandy campaign in 1944. On July 27th, near the village of Le Loret, Bachmann's single Panther engaged a column of American Sherman tanks. Over approximately 20 minutes, Bachmann destroyed 9 Shermans and several other vehicles. His Panther's frontal armor deflected multiple hits. He withdrew without significant damage. Similar engagements occurred throughout 1943-1944. A well-positioned Panther with a trained crew could dominate a battlefield. The combination of armor protection and firepower gave the Panther overwhelming advantages in tank versus tank combat. But these advantages were negated if the tank broke down, caught fire, or ran out of fuel before reaching combat. The mechanical problems gradually improved through 1943 and 1944. Later production Panthers, designated AAUSs Serpav A and Ausserford G, incorporated numerous improvements. The transmission was strengthened. The cooling system was improved. The fuel system was made more reliable. By late 1944, Panther reliability was acceptable. A well-maintained Panther could operate for 1,000+ kilometers between major overhauls. But even reliable Panthers faced operational challenges. The Panther consumed enormous amounts of fuel. The gasoline engine burned approximately 480 liters per 100 kilometers on roads, more in combat conditions. Germany was suffering fuel shortages by 1944. Panthers were often immobilized not by mechanical failure but by lack of fuel. Crews would abandon serviceable tanks because they had no gasoline. Ammunition supply was less problematic but still challenging. The Panther carried 79 rounds of 75mm ammunition in various types: armor-piercing, Panzergranate 39-42, high-explosive, Sprenggranate 42, and armor-piercing composite rigid, Panzergranate 40-42. In sustained combat, a Panther could fire its entire load in less than an hour. Resupply required bringing ammunition trucks forward, which exposed them to enemy fire. The Panther's tactical employment evolved as crews gained experience. Early doctrine called for Panthers to lead attacks, using their armor to break through enemy positions. This resulted in high losses to mechanical failures and mines. Later doctrine used Panthers more conservatively, in supporting roles, providing overwatch fire while other vehicles advanced, or in defensive positions where their armor and gun could be used effectively without excessive movement. In defensive combat, the Panther excelled. A Panther in a prepared hull-down position with good fields of fire and infantry support was extremely difficult to dislodge. Allied forces learned to avoid frontal attacks against Panthers. They would use artillery, airstrikes, or flanking maneuvers rather than direct tank assaults. Soviet forces developed specific tactics for fighting Panthers. The T-34-76 couldn't penetrate the Panther frontally, so Soviet tactics emphasized numbers and maneuver. Multiple T-34s would engage a Panther simultaneously from different directions. While the Panther engaged one tank, others would maneuver to the flanks and rear. Soviet tank hunters with anti-tank rifles or satchel charges would infiltrate close to Panther positions. Artillery would be used to suppress Panthers before tank attacks. The Soviets also developed better tanks to counter the Panther. The T-34-85, introduced in early 1944, mounted an 85mm gun that could penetrate the Panther's frontal armor at ranges under 500 meters. The IS-2 heavy tank's 122mm gun could penetrate the Panther at longer ranges. These weapons reduced the Panther's armor advantage somewhat. Though the Panther remained formidable, American and British forces encountered Panthers primarily in Normandy and the subsequent campaign across France and into Germany. The standard Allied medium tank was the M4 Sherman. The Sherman's 75mm gun could not reliably penetrate the Panther's frontal armor at any combat range. Allied tankers learned quickly that engaging Panthers frontally was futile. Allied doctrine emphasized combined arms. Infantry would locate Panther positions. Artillery would engage them with indirect fire. Tank destroyers with higher velocity guns, like the M36 with 90mm gun, would engage Panthers at range. Fighter bombers would attack with rockets or bombs. If Sherman tanks had to engage Panthers, they would use numerical superiority to flank them. The psychological impact of the Panther on Allied tank crews was significant. Crews knew that if they encountered a Panther, their survival depended on getting to its flanks or rear. Frontal engagements were likely fatal for the Sherman. This created anxiety and affected tactical decisions. Some crews became overly cautious. Others became reckless, taking excessive risks to get firing positions where they could damage Panthers. The Panther's production numbers tell an interesting story. From January 1943 through April 1945, Germany produced approximately 6,000 Panthers. This was significantly less than the number of Panzer IVs, over 8,500, or Stu G3 assault guns, over 10,500, but substantial nonetheless. The Panther became Germany's second most numerous tank design by mid-1944. Production was concentrated at MAN in Nuremberg, Daimler-Benz in Berlin, and MHN in Hanover. These factories were targeted by Allied bombing raids throughout 1944-1945. Bomb damage disrupted production repeatedly. Despite this, production peaked at over 350 Panthers per month in mid-1944. The manufacturing process was complex. The Panther's interleaved wheel suspension was particularly difficult to produce. Each road wheel had to be individually machined and fitted. The overlapping wheels created a system that was maintenance-intensive. If an inner wheel was damaged, the outer wheels had to be removed first, a time-consuming process. In winter, mud and snow would freeze between the wheels, immobilizing the tank until it could be thawed. These practical problems affected the Panther's combat effectiveness as much as enemy action. A technically superior tank was useless if it couldn't move. German maintenance crews worked constantly to keep Panthers operational. They became expert at field repairs, cannibalizing parts from knocked-out vehicles, improvising solutions to problems that normally required factory repairs. The Panther's crew consisted of 5 men: commander, gunner, loader, driver, and radio operator, hull machine gunner. The commander had excellent visibility from the turret cupola with 7 periscopes. He could see in all directions without exposing himself. The gunner had a monocular telescopic sight for the main gun. The loader worked in the turret, loading the main gun and operating a roof-mounted machine gun. The driver sat in the left front hull. The radio operator sat right front and operated the hull machine gun and radio equipment. Crew training was extensive. Panther crews trained for months before being committed to combat. They learned gunnery, tactics, maintenance, and crew coordination. Well-trained crews were significantly more effective than inexperienced crews. A veteran crew could engage and destroy targets quickly while maneuvering to optimal positions. Green crews made mistakes that got them killed. The crew experience in combat varied widely. Some crews described the Panther as the best tank they served in: powerful, well-protected, comfortable. Others described it as a maintenance nightmare that was constantly breaking down. The difference often depended on the specific tank, early versus late production, the maintenance support available, and the tactical situation. Crew casualties in Panthers were lower than in earlier German tanks due to the better armor protection. When a Panther was penetrated, the effects were often catastrophic. The ammunition exploded or fuel ignited. But penetrations were less frequent than with earlier tanks. Many Panther crews survived multiple combat actions, something less common in Panzer IIIs or IVs. The Panther's ammunition was sophisticated. The standard armor-piercing round, Panzer Granit 3942, used a ballistic cap design. The cap improved penetration against sloped armor and maintained velocity. The round had excellent accuracy at range. Experienced gunners could hit targets reliably at 1,500 to 2,000 meters. High explosive rounds were used against soft targets and fortifications. The 75mm HE round was effective against infantry, trucks, and buildings. It was less powerful than larger caliber guns, but adequate for most situations. Late in the war, the Panzer Granit 4042 tungsten core round was introduced. This had even higher penetration than standard AP rounds, but required scarce tungsten. Production was limited. Only priority units received these rounds regularly. The Panther's gun depression was 8 degrees, adequate for most terrain. Gun elevation was plunging 20 degrees. The turret traverse was powered by the engine through a hydraulic system, which allowed fast traverse when the engine was running. Manual traverse was also possible, but much slower. The gun could traverse 360 degrees, though some angles were restricted by hull obstacles. Fire control was good by 1940 standards. The gunner's sight had range markings for different ammunition types. A separate commander's override allowed the commander to traverse the turret and indicate targets to the gunner. The rangefinder was optical. The commander or gunner estimated range based on target size and adjusted fire based on observation. Accuracy was excellent. Test firings showed that a Panther could consistently hit a 2.2-meter target at 1,000 meters. At 2,000 meters, hit probability dropped, but was still acceptable. This long-range accuracy gave the Panther a significant advantage. It could engage and destroy enemy tanks before they could return effective fire. The Panther's mobility was good when mechanical issues didn't interfere. Top speed was approximately 55 km/h on roads, though this was rarely achieved in combat conditions. Cross-country speed was 20 to 30 km/h, depending on terrain. The suspension provided good ride quality. Crews reported that the Panther could traverse rough terrain at speeds that would break other tanks. The wide tracks, 660 mm, gave good ground pressure and reduced bogging in soft terrain. This was important on the Eastern Front, where mud was a constant challenge. The Panther could traverse terrain that bogged down other vehicles. Fording capability was 1.7 meters without preparation, up to 4 meters with snorkel equipment. This allowed Panthers to cross rivers that would stop other vehicles. Several combat actions involved Panthers crossing rivers to outflank enemy positions. The Panther's radio equipment was the Fuji-5 radio set, providing voice communication between vehicles and with higher headquarters. Range was approximately 4 kilometers for vehicle-to-vehicle communication, more to powerful base stations. Clear communication was essential for coordinating tank actions. Interior conditions varied. The crew compartment was relatively spacious compared to earlier German tanks. Visibility was good. The commander's cupola provided excellent all-around vision, but the interior was cramped when all equipment, ammunition, and personal gear were loaded. In summer, temperatures could exceed 50 degrees. In winter, heating was inadequate. Combat conditions were exhausting. Maintenance requirements were substantial. The Panther needed regular oil changes, track adjustment, suspension checks, and cleaning. In combat conditions, maintenance was often deferred until mechanical problems developed. Crews were supposed to perform daily maintenance checks, but time and resources weren't always available. German logistics struggled to support Panthers in the field. The tank required specialized spare parts that weren't interchangeable with other vehicles. When parts weren't available, Panthers would be cannibalized to keep others running. By late 1944, entire Panther battalions were reduced to half strength due to mechanical casualties that couldn't be repaired. The Panther's combat debut at Kursk was a mixed success. The tank's armor and gun performed as designed. Panthers destroyed numerous Soviet tanks, but the mechanical failures were catastrophic. More Panthers were lost to breakdowns than to enemy action in the first week. German commanders were frustrated. They had a technically superior tank that couldn't stay operational. After Kursk, improvements were implemented. The most serious mechanical issues were addressed. Panther reliability improved significantly by late 1943. By 1944, the Panther was Germany's most capable tank when properly maintained and adequately supplied. In Normandy, Panthers were deployed in both offensive and defensive roles. When used defensively in prepared positions, they were highly effective. Allied forces suffered heavy tank losses attacking Panther positions. When Panthers were used offensively to counterattack Allied advances, results were mixed. Fuel shortages and mechanical problems limited operational effectiveness. The Battle of the Bulge in December 1944 saw concentrated Panther employment. German forces deployed several Panther-equipped divisions in the surprise offensive. Panthers spearheaded attacks, exploiting their mobility and firepower. Initial successes were impressive, but fuel shortages crippled the offensive. Panthers were abandoned when they ran out of gasoline. Mechanical failures increased as tanks were pushed beyond their operational limits. By early 1945, Panther production was declining due to bombing damage and material shortages. The tanks reaching frontline units were often poorly finished and mechanically unreliable. Crew training was abbreviated as Germany suffered manpower shortages. The Panther remained dangerous in combat, but organizational and logistical collapse meant they were often employed piecemeal rather than in concentrated units. The final Panthers fought in the defense of Germany in 1945. Individual tanks or small groups fought delaying actions as Allied forces advanced. Some Panthers were dug in as static defenses, using their armor and gun to cover roads and approaches. These final battles were one-sided. Allied forces had overwhelming numerical and air superiority. Panthers that engaged were quickly targeted by artillery or airstrikes. The last Panthers in combat were probably in Berlin in April-May 1945. Several Panthers were positioned to defend key bridges and approach routes. They fought until destroyed, or their crews surrendered. The Panthers' war ended in the ruins of the city, where the MAN factory that produced them was located. Post-war, the Allies thoroughly evaluated captured Panthers. American, British, and Soviet engineers examined the design carefully. Reports praised the gun and armor, but criticized the mechanical complexity and reliability. The consensus was that the Panther was an excellent combat vehicle, compromised by poor reliability and excessive resource requirements. The French army used captured Panthers for several years after the war. These tanks were designated Panther M47 and served until better vehicles were available. The French experience confirmed that Panthers were capable when properly maintained but required substantial logistical support. The Panther influenced post-war tank design significantly. The concept of sloped armor became universal. Most post-war tanks featured heavily angled armor rather than vertical plates. The emphasis on long-range firepower also became standard. Post-war tanks mounted high-velocity guns capable of long-range engagement. Soviet tank design showed clear influence from both the T-34 and captured Panthers. The T-44 and later T-54-55 incorporated lessons learned from examining Panthers. The emphasis on sloped armor, powerful guns, and mobility reflected both Soviet experience and German engineering. Western tanks like the American M47 and M48 Patton series showed less direct influence but still incorporated many Panther-inspired features. The emphasis on armor protection through sloping and the use of high-velocity guns reflected lessons learned from fighting Panthers. For Lieutenant Ivan Zhdanov, the Panther represented a technological shock. His first encounter demonstrated that the Soviet tank advantage of 1941-1942 had been overcome. Germany had developed a tank that could destroy T-34s with impunity while remaining essentially invulnerable to Soviet return fire. Zhdanov survived the Battle of Kursk. He was given another T-34 and continued fighting. He participated in the Soviet offensives of 1943-1944. He encountered Panthers multiple times. Each engagement reinforced the same lesson: avoid frontal engagements, use numbers and maneuver to get flank shots, call in artillery when possible. Zhdanov survived the war. He remained in the Soviet army until 1953. He rarely discussed his combat experiences. When he did, he always mentioned the Panther, the tank that deflected his shells, the tank that destroyed his vehicle with one shot, the tank that represented Germany's technical capability at its peak. The Panther's legacy is complex. It was one of the best tanks of World War II in terms of firepower and armor protection. The sloped armor design was revolutionary. The gun was among the most powerful mounted on any medium tank. But the mechanical problems, resource requirements, and limited production numbers meant the Panther never achieved the impact it might have had. The Panther demonstrates an important military principle. Technical superiority doesn't guarantee success. A brilliant design can be compromised by manufacturing problems, logistical limitations, or operational circumstances. The Panther was technically superior to virtually every Allied tank it faced. But that superiority was negated by mechanical unreliability, fuel shortages, crew training inadequacies, and overwhelming Allied numbers. Modern tank enthusiasts and historians debate the Panther's effectiveness endlessly. Some argue it was the best tank of World War II. Others point out that reliability matters as much as firepower. A tank that breaks down isn't contributing to combat power. A design that requires scarce materials and excessive production time isn't practical for mass warfare. The truth is probably that the Panther was both excellent and flawed. Excellent in its armor and firepower, flawed in its mechanical complexity and resource requirements. The tank that Soviet Lieutenant Zhdanov saw at Kursk on July 5, 1943, represented Germany's last major tank innovation. It came too late, in too few numbers, with too many problems. But when it worked, it was formidable.